Do you hear me? Do you hear me? Great. So let's start. One of the most complex examples we'll solve this semester. We have a cylinder. Its mass is m, the radius is r, the friction of the constant is mu, and we pull it with the force F. Of course, we can use the easiest boundary condition like xt equals 0 is 0, vt equals 0 is 0, initial angular displacement is 0, and the initial angular velocity is also 0. Yes. So it's computer science engineer, not informatics, sorry. Alright, how will it move? Do you remember what is pure rolling and non-pure rolling? What is the key point? We distinguish these two kinds of motions. Let's go back at first for the incline example. We have a box with m, and there's a mu, and there's alpha, and so on. At the very beginning, we divided the weight into parallel and perpendicular component, and we checked whether the static friction, which has a maximum value like mu times g perpendicular, whether it's enough to compensate the g parallel. If Fs, the static friction, can be large enough, the box won't move. If it's not large enough, the box will move, but its net force will be parallel minus, and if the static friction is not enough, we can talk about kinetic friction, which is mu times g perpendicular. I hope you still remember how we solved this example. So at the very beginning, we have to suppose something, that this is the box doesn't move. We checked its condition. When it was true, it was the end of the exercise. It's not. If not, we have to solve with the condition for kinetic friction. We should do the same thing. Pure rolling means even if it moves, the pure rolling means the force here, I used to write there T, the force is a static friction. Static friction means something doesn't move. And if you look at the wheel, how it moves very, very carefully, the point where it touches the road, this point does not move. Opposite to the situation when this is an icy road, and even if you block your wheel, so there is the angular velocity is 0, this point will move since the whole car or whole bicycle can move in a transversal motion. No rotation, only transversal motion. Pure rolling means pure rolling, this is a static friction and not a kinetic friction. Alright, try to solve it with some assumption, and this assumption again is that this is a pure rolling. What are the equations I should use? For translation, which is the sum of the forces equal m times a. For translation, sum of the forces equal m times a. Well, this upper part of the table is still not okay. Let me write here. For translation, sum of the forces equal m times a. And there must be some a, since we can see that can move. What are the forces? Let's create a coordinate system like x and y. What about x forces? So along the x, we have this force, how we pull it, and minus t, which is also along the x-axis, but it's opposite to the positive direction of the x-axis. This will be m times ax. For y, we have a weight and also a reaction force. Oh, by the way, the positive direction is for the reaction force. Reaction force minus the weight equal MAY. But we know, since this is a solid surface, this F force won't lift the body, and this body also can go into the surface, so that must be 0. That means these two forces has to be the same, only the direction is the opposite. So we can technically forget this part. What other conditions? So the first is the x motion and the other is the rotation. The rotation, the dynamic equation for rotation means the sum of the torque or torques, torque U's, has to be equal moments of inertia times angular acceleration. So look at the picture. You can draw the line of action of the F force, and since it goes through the axis of the rotation, which is the center of this cylinder, the torque U from torque from F is 0, since the F times D is the tau, and since D equals 0, this is 0. Oh, you can't see it. F times D, and this is 0. Even worse. So the F times D, but since D equals 0, that will be 0. So let's look at the only force which has any level arm, and the level arm is the perpendicular distance of the force and the axis of the rotation, and in this case this level arm is the radius. So the T rotates via R, and that will cause angular acceleration through the moments of inertia. Moment of inertia times alpha. So we have one equation for translation and one equation for rotation. And let's say this is pure rotation. What does it mean, pure rotation? Pure rotation wait a bit, means that the velocity of the body, the center of mass, equal r times omega, and the angular acceleration is r times alpha. How can we use it here? I think that was not the best. This is a pure rotation. You can imagine there is a cylinder that rotates via omega, and in this case, this lower part, the one point of the edge of the cylinder has v times omega velocity, this direction, and at the upper part, that direction. What if I add a pure rotation and a pure translation, but with the velocity which is equal to omega times the radius? If you add it, you will see that in this case the center of the rotation does not move, so it's pure rotation. By pure translation it moves like v, the sum will be v. On the upper side there is one v equal omega times r plus another v equal omega times r. The v will be doubled, and in the lower part, since we have the same velocity but with opposite direction, this part here, there is no v here, which means it's stopped. So every pure rotation, when we move with our bicycle, the point when the body where the body touches the surface, that's stopped. So, and this is the reason why it can be do is because of the friction. This friction is large enough to stop that point. That does not mean that the whole wheel won't move. So this is opposite the situation like the incline plus the boxes. The large enough friction means we have a pure rotation. If it's not large enough, that's a non-pure rotation, that's another story. So the pure rotation can be formalized like A or AX equal R times alpha. So, and this is the three equation what we have to solve because we have three unknown. All right, let's try to solve it. I clear the table. You can download the pictures later if you want. And let's solve something. So just use these data and let's collect the equation. So we have f, so let's assume this is a pure rotation, f minus t equal m times a. The t rotates via r equal moments of inertia times alpha, and the a equal r times alpha. So these are the basic equations, but only with the assumption that this is a pure rotation. If it's a non-pure rotation, the third equation can't be true. Let's replace with numbers. So 450 minus t equal 100 times a. T times 1 equal 1 over 200 times 1 square times alpha, and a equal r times alpha. Pure rotation means the friction can be large enough for the pure rotation, but we know for the friction we have an upper limitation mu times weight, because this weight is the perpendicular force. So since we know mu equals 0.6 and the mass is 100, so it's 600 Newton, the maximum possible friction for static friction. So let's solve at first this part. So this is T equal 50 alpha, but we know the R is 1, so the nominal value for alpha and A is the same. So we can write T equal 50 A. Let's use it here. Oops. 450 minus 50A equal 100A. 450 equal 150A. A is 3. And since we use SI units everywhere, this is meter per S square. Alpha equal A over R, 3 over 1. So this is 3, 1 over S square. That's great, but we have to check at first the condition, whether it's a pure rotation, whether the static friction is enough. And therefore, let's go here. If T equal 50A, the T 50 times 3 equal 150, and since we use SI units, this is Newton. So the question, when it's pure rotation, is the 150 smaller than 600? The answer is yes. So the pure rotation condition is true. We can go further, but right now we more or less finished. So we know the A equal 3 meter per S square, angular acceleration is 3, 1 over S square, and the friction is 150 Newton. Let's answer some questions. For example, if x t equals 0 equals 0 and v t equals 0 is 0, where is the body at 10 seconds? I give you alpha is the angular acceleration. 1 second. At the very beginning of the rotation, oh, that's beta here, sorry. Alright, I will change it. So, angular displacement, angular velocity, angular acceleration. In some book this is alpha, and in some other books beta. I copied paste in the wrong order. So this is alpha, the angular acceleration. Oh, here we have in the right naming conversion. So this is what's happened if we derive the angular velocity by time. All right, let's go to the example. Please answer it. Where is the body in 10 seconds? If this body is a cylinder and we pull with the force 150 Newton through its axis of the rotation, and we calculated what is the acceleration, it's pretty easy to calculate where is the body at 10 seconds if the boundary conditions are like this. So, and now I give you 5 minutes. All right. I make a bit more space here. So if we know we have a body, and now it's only about translation. We have a body. All right. So what we calculated, with that force, that mass, that radius, that mu, the acceleration will be 3 meter per square. What if at t equals 0, I had x equals 0 and t equals 0, my velocity is 0. Where is the body in 10 seconds? Yes, I think so because it's a very easy question. So xt equals 0. If we do all the double integral plus boundary condition, at the very end, we will have a formula like this. All these are 0, and the result is A3, 3 over 2 times 10 square, that will be 150 meter. All right, that was the not that interesting situation. Now look at it. I've only changed the mu to 0.1. Again, I will start with the assumption that this is pure rotation because I can't do anything else. So pure rotation means F minus t equal m times a. T rotates through the angular acceleration, through the moments of inertia, and the pure rotation condition is r times alpha, and of course the t has to be smaller, equal than mu times weight. If you solve it, and everything is the same, but only, so you will get that t equal 150 Newton, a equal 3 meter per square, alpha equal 3 1 over s square. So the way how we get it, this is just the same before. But the upper limit for the static friction is 100, which means it can't be static friction because we would need 150 for pure rolling, but we have only 100. So it will slip like the wheel on the icy road. In this case, we have to forget the pure rolling. That will simplify the situation, but of course for this answer at first we have to solve the pure rolling, because pure rolling, that's equivalent to a times a equal r times alpha. That's also not true. There is no, this is alpha here, a equal r times alpha is not true again. worse and worse, but you can combine these two. All right, how can we solve that? Since the A is not R times alpha, but so we lost one equation, we still have 3 unknown Ta alpha, but we gain one other equation by the kinetic friction, which is equal to mu times g, which is 100 Newton. So in this case, we don't have to calculate by solving all of the equations the t, because it's at the beginning, this is a well known, since this is not a pure rolling, the wheel slips, it's a kinetic friction is equal to mu times perpendicular force, which is the weight. And look at it, in this case, if we say F minus T equal M times A, we don't have to combine any more equations, since this is 100. 50 minus 100 equal 100 times A. The A is 3.5 meter per s square. That was for translation. For rotation, I times alpha, it's 100 times 1 equal 1 over 200 times 1 square times alpha. That means 100 alpha equal to 1 over s square. So in this case, when I ask you where is the body at t equal 10 seconds, you should use this A. Xt equal 10 seconds is 3.5 divided by 2 times 100, 175. Do you remember what was the xt equal 10 seconds in the pure rolling condition? That was 150 meter, and now this is 175. Do you know what is ABS in the car? What is this mosaic word? A, B, and S. This is anti-blocking system. Yes. So why do we have such electronics for the cars? Because ABS try to keep the condition for pure rolling, because that was true for acceleration, but that's only true for deceleration. If we use the same force, if we use a force for stopping the car, and if the condition is non-pure rolling, that means the car will stop by 175 meter, and if this is pure rolling managed by the ABS system, the car can be stopped earlier. That's mainly for safety. Of course, the car won't stop in 100 meters, it stops in 30 or 50 meters, but the philosophy behind it, if we can always keep the condition for pure rolling, you can stop earlier. All right. And now R equal 1 meter, F equal 150 Newton, M equal 100 kilogram, mu equal 0.3. Can you answer the question whether it's pure rolling or not? And where is the body in 10 seconds? I talked, but my microphone was off. So I get a mail that I will have a meeting in 10 minutes, so try to solve it. So based on the equation, try to solve exactly this example with 0.05 and 0.8. I uploaded this exercise in the Moodle. I'm left with only finding x. All right. So what was your acceleration? What about the second test? If you can come, if you can come to the university, you can write it on the last days of the seminars. If not, but you can come for doing your exam 3/5. All right. I also type it for the others. So option 1, you can come to the uni and write the test in the last days of the semester. Option 2, you can't come to write the test, but you can write the exam offline. In this case, no test 2. The test 2 will be part of the exam. So in the exam will be theory plus practice. I will mail the ones they failed the test 1 or forget to write it. But otherwise, this is the option. Option 3, we can't meet till the next semester. In this case, the exam will be online and theory plus test 2 together. I mean, sample test, exactly you will solve this example. Cylinder forth through the axis of the rotation, and what is the acceleration, and where is the body in 10 seconds. That's all. I mean, it's pretty long. I mean, for test 1 is enough. Of course, if you worry about missing this test, you will get a bad grade. I can add a seesaw example if you want. It's up to you. A seesaw plus a cylinder, a rolling cylinder. So, do you want to have two question in test 2? All right, but since right now you are the only one here, all right, ask the others. Ask the others, let me know. For me, both options is okay. Of course, if there's only one question, you have to be absolutely sure that you can solve the one question, because if you fail the one question, you fail the test too. But I think it's not that complex to fail it. And by the way, Sorry, I have to leave and see you next Monday. Bye, and thanks for the participation.